In this video, we're going to look at compound interest. In the first example, it asks, what is the future value if $3,200 is invested for 5 years at 8% compounded quarterly? So let's take a look at the formula and talk about each variable and what it represents, and then we'll get started on the problem. So we have A is equal to P times 1 plus R over M raised to the MT. So A is your accumulated value. So this is the money that you invested and the interest made. P is the principal amount, so your initial investment. R is your nominal rate. M is how many times it's compounded per year. And then T is in time for years. So in this problem, we want to find future value, so we want to find A. So A is equal to our principal amount, which was $3,200, times 1 plus our rate divided by our compound. And our rate is 0.08 for 8%, divided by, we're compounded quarterly, so our M is equal to 4. And we invested it for 5 years, so we have 4 times 5. So now let's simplify all this. We have 3,200, and 0.08 divided by 4 is 0.02, so we have 1.02, and 4 times 5 is 20. So now we can calculate with our calculator, and when we do that, we get 4755.03. And remember, that's dollars. So if we invest $3,200 for 5 years at 8% compounded quarterly, we would have $4755.03. In the second example, the question asks, what present value amounts to $10,000 if it is invested for 10 years at 6% compounded annually? So now it's asking us for a present value or a principal amount. So we know A is 10,000 equals to, now we're looking for P, and we know that we have 1 plus our rate, which is 6%, 0.06, divided by compounds, and it's compounded annually, so this is 1, raised to the MT, and M was 1 times T is 10. So we have 10,000 is equal to P times 1.06 raised to the 10th, and then P is equal to 10,000 divided by 1.06 raised to the 10th. So our principal amount was equal to $5,583.47. So we have to invest $5,583.47 at 6% compounded annually for 10 years in order to have $10,000 in our account. In this next example, we have at what nominal rate, compounded quarterly, would $20,000 have to be invested to amount to $26,425.82 in 7 years. So here we're trying to find R. So we know A is equal to 26,425.82, and that's equal to P, which is 20,000, times 1 plus R, because that's what we're trying to solve for, divided by 4, because we're compounded quarterly, raised to the MT, which is 4, and time was 7 years. So we're going to divide both sides by 20,000, and we get 1.321 is equal to 1 plus R over 4 raised to the 28. And now I'm going to raise both sides to 1 over 28. So I have 1.321 to the 1 over 28 is equal to 1 plus R over 4 and we get 1.01 is equal to 1 plus r over 4. And now we subtract 1 from both sides, and we get 0.01 is equal to r over 4. And then multiply both sides by 4, and we get r is equal to 0.04 or 4%. So the nominal rate is 4%. If we compound quarterly and we invested $20,000 for 7 years, we would have $26,425.82. In this last example, we have how long in years would $700 have to be invested at 11.9% compounded continuously to earn $300. Now this formula is a little bit different for compounded continuously. We have A is equal to principal times E raised to the RT. So now our A is equal to our accumulated, and we started with $700 and we earned $300 in interest. So we have $1,000 for our A is equal to our principal, which was the amount we invested, $700, E to the RT. And we're trying to solve for time, so we're going to have 0.119 T. And the first thing I'm going to do is divide both sides by 700. So I have 10 divided by 7 is equal to E to the 0.119 T. And now I'm going to ln both sides. So I have ln of 10 divided by 7 is equal to 0.119 T. And then T is equal to the ln of 10 divided by 7 divided by 0.119. And when we calculate this, we find that T is equal to 3 years. So it takes 3 years with an investment of $700 at 11.9% compounded continuously to earn $300 in interest. And that's our video on compound interest.